Okay, in the section number 2, we will discuss about the homogeneous linear ODE with constant coefficient. So in the previous session, we discussed about the second order in the form of this one plus px y prime equal to qx y equal to 0, and this one if px the function of x equal to constant. So we have the linear, the homogeneous linear with constant coefficient. We can have the A, the B, A for the P, F, and QX for represented by B because it's constant. So if we have this one, the solution is more simple. It's simpler than previous. So the equation have constant application in mechanical and electrical vibration. And so have to show the second order homogeneous linear with the constant coefficient. So go back to the previous session. If we have the first order linear equation with the constant coefficient like that, so we can obtain the solution in the form of this c equal to exponential kx. Okay, so this will inspire us by we can the first equation, the basic equation of the second order by this one. So y equal to e of exponential of lambda x lambda x. Okay. So we have the y prime equal to a y prime as plus b y equal to 0, and if we assume that equal to exponential lambda x, the solution of this equation, namely equation 1. So we will calculate the y prime equal to lambda e lambda x, and y double prime equal to lambda scale e lambda x. So substitute this into the first equation, we obtain lambda scale e lambda x plus a lambda e lambda x plus b e lambda x equal to 0. And if we prove, we have the e lambda x equal to lambda scale plus multiply a lambda plus b equal to 0. That means if this one is a solution, so we can imply that if y equal to e lambda s is solution. So this one with the number 2. So the number 2 must be satisfied, and must be satisfied. That means we have this is not 0. This cannot be 0, so this must be 0. So lambda cell plus a lambda plus b must be 0. that must be satisfied, so it must be zero. In this case, we can say that, and this equal the characteristic function equation. This is the characteristics equation equation of one of the second order ODE. The characteristic equation. Characteristic. Okay, characteristic. Okay, and if we have the lambda is the from the characteristics, so we have the lambda one, lambda two, a root of the characteristics equation. So we obtain the basic function y1 equal to e lambda one x and y2 equal to e lambda two x. Okay, so if in conclude, if we have the second order represented by plus a y prime plus b y equal to 0, we can have the characteristic equation of this equation of the second order ODE equation is represented by lambda cell equal to a lambda equal to plus b and b0 to equal to 0. This is a characteristic equation and called and equal characteristic equation and characteristic equation. Okay, and the characteristics equation is a characteristic equation. They can have the solution, and we have the 3k. And in order to show this equation, we usually have the data equal to bb. B scale minus for A for C. In this case, namely, B scale, that means A scale minus for B, for B because A is equal to 1, for B is this one. Okay, so we have 4 cases as 3 cases first. We can have that the delta is positive, meaning a scale minus probably is positive, and specifically in this case we have two separate or two distinguished. We have two distinct that means separable distinct real. We have real root specifically y lambda 1 equal to minus lambda y equal to minus a minus square root delta because it is b in the this and a equal, and lambda 2 equal to minus a plus square root delta over 2 divided by 2. So and we can apply the y equal to e lambda 1 and y2 equal to e potential of lambda 2x. And eventually we have the y equal to c1 e lambda 1x plus c2 e lambda 2 added in the equation for the solution. In the first case, okay, it's clear. It's clear. Because in this case, we have these two distinct real root. In the second case, before go to the second case, we have the we can get the example. So we can get the example, for example, for more detail. example. Find the solution of this one. Y double equals plus y price minus 2y equal to 0. And I have the initial condition y0 equal to 4 and 5 times 0 we have the minus 5. Okay, so we can find. From this equation, the second equation we can find out, we can figure out the characteristic equation like that. So in this case, we have the A equal to 1 and B equal to minus 2. So the characteristic like that, A lambda and B 2 equal to 0. So we can have delta equal to 1 scale minus 4, that means A equal to plus minus and minus and 9. So eventually we have lambda 1 equal to minus 1 minus 3, 2 equal to minus 2, and lambda 2 equal to 1 minus 1 plus 3 over 2, that means 1. Okay. And we can have the y1 and y2. So eventually you can write y equal to what c1 e minus 2x plus c2 e exponential minus x. So we have the initial, remember, so they we have initial 0, 4. So this means, so we have this general solution. So we have C1 0, 0 equal to 0, 0, 0, 0, you know, C1 0, that means C2. So the first, we can find the C1 and C2, or we can find a specific value of arbitrary constant C1 and C2. But however, we have two variables, but we have only one equation. It's impossible to find out the specific value of C1 and C2. So we need more equation by use the equation, the initial condition 0 to minus 5. So for this one, if we get the first derivative, so we have 2c1, 2c1, right? 2c1 minus 2c1 minus 2c1 plus c2. Because we get the derivative, it's almost same, equal to 5. So from the two equations, we can easily find specific C1 and C2. For this case, C1 equal to 3 and C2 equal to 1. Okay, and we can have it for this one. So we can have the solution for this can be write out like that. So y equal to EF plus 3 minus, or we can write okay, C1 and 3 E2 x minus 2x plus C x. Okay, so the final solution. In this case, in the first case, we have the separate rules of the characteristic equation. Okay, we will next example delta equal to the delta. In the second case, we have the delta L plus A delta plus B equal to 0, and we have delta lambda delta equal to A minus 4B. And in this case, means 0, 0, that means we have the double real root lambda equal to minus A2. We have, and in this case, we have y1 equal to E A2x. And we have only one, and we have to find the number two. So remember that even though in the characteristics equation we have double root, so we can have double root of the second order equation. It must be separate E1 and E2. Remember that. Even I want to, you should keep in mind that even though we have two the same lambda 1, lambda 2 equal to lambda 1 and lambda 2 for in this case. So first, it doesn't mean we have E1 equal to E2. Not doesn't mean it's completely different. So in this case, we have only y1 equal to E lambda s, and we have to find y number 2 by what? By y, by how? By use this reduction of order. We already discussed in the section number 1. So, and step by step, you can find the second. You can find the second solution, E2. So eventually, you can have the y2 equal to x y1. This you can keep in mind. You don't need to show step by step. Actually, you did reduction. You can find this one, and we can use the final equation. In this case, you don't need to show step by step in this case, and eventually we have the equation. Second order have two separate basic. That's E1 equal to E lambda x with lambda root of the characteristic equation, and 2 equal to x x E lambda x. So we have the 0 to C1, C2, because we gave group this one almost same. So C1, C2, and C2, we have x, C2, or C2x equal minus A2 x. So this is the equation we can use. You don't need to show step by step from this one to this one. And what is the last case? The last case we have the delta equal to a scale minus 4b, and in this case it is negative. So we usually say that it's negative, so we have no root. No root. Actually, this is not true completely. In this case, we have two complex roots. If we consider in the complex number, we have two complex roots, especially will be the lambda will be 1, 2a minus 1, 2a plus I omega, and lambda equal to lambda 1, lambda 2 equal to minus 1, 2a minus I omega. So in this case, we also have two solutions, two basic of equation y1 equal to AF over to cosine omega s, and second basic of solution is equal to correspondent AF Sorry, similar to this one. We can write the formula. Okay. Minus AF over 2 and sine omega, omega x. Okay. And eventually we can obtain the solution for C1. C1 in this case we will not use C1. So we can use the A and B instead. AX to we use A and B. So we have A. This is, remember that A similar to C in the previous show. However, in this case we use A cosine omega x plus B sine omega x with A and B in arbitrary. Arbitrary. So this one is similar. If we have the initial value, we can easily find the value of A and B for the specifically a specific solution. So we will summarize for the section number 2. If we have the second order equation represented by this form with the constant coefficient plus b y equal to 0, then we constant a and b. Now first we have to find the characteristics equation of this equation by this one a lambda plus b equal to 0. This is the characteristic equation, and we try to find the root of characteristic of this one by calculating a minus 4b. If they have the distinct separate real uh, root, specifically lambda 1 and lambda 2, we can imply the basic of solution like that, the potential of this one. And eventually we have a general solution of this second equation by the combination of C1 and Y1 and Y2. And next, in case of this characteristic equation have the real double roots, and in this case we have only one root, and we can calculate another basic solution by this one. And remember that equal to x multiplied by the first, almost similar. So we can use the equation, and finally we obtain the general solution for this one. And the last one, in this case, we have the complex roots. So we have lambda 1 and lambda 2 is complex number. So we obtain the general solution by this equation. And similar to previous, according to the condition, initial condition, we can find out the specific value for the arbitrary constant C1 and C2 as well as A and B in this equation, for example.